Hey everyone, welcome to Unit 3, Lesson 9, Introduction to Parallel and Perpendicular Lines. So what happened to Lesson 8? Well, there wasn't a Lesson 8 because there was a Homework 8, which was basically reviewing writing linear equations of all different types with 2 points or slope and whatever. So we are on Lesson 9, which parallels with Homework 9, and it actually does talk about parallel and perpendicular lines. So let's get started. What are parallel lines? Parallel lines are lines that never intersect. Lines that never intersect. And what that means is they never cross. Okay? They never intersect, they never cross. So it looks like this. These are this is a pair of parallel lines or lines that never intersect. So what does that look like algebraically? Well, algebraically, how do we know if they're parallel? Well, they have the same slope. They have the same slope. So parallel lines have the same slope. They lean in the same direction. They lean the same way. They have the same inclination or slope, which means that they'll never cross each other. So for example, y equals 2x plus 1 and y equals 2x minus 7. These are, without looking at them, these are parallel lines. These two linear equations represent parallel lines because the slopes are the same. The slopes are both 2. Perpendicular lines are lines that do intersect, but specifically, they are lines that intersect at 90-degree angles. Lines that intersect at 90-degree angles. That's what makes them perpendicular. So when they cross, they make 90-degree angles, okay? How do we know, this one's a little trickier, how do we know algebraically that the lines are perpendicular? Well, perpendicular lines have opposite reciprocal slopes. Did I write that right? Reciprocal. There we go. Opposite reciprocal slopes or opposite flip slopes. So meaning, if I have one line called y equals 2x plus 1, then a perpendicular line to that would be y equals negative 1/2 x, let's say, plus 5. So these are two different lines, but they are perpendicular because their slopes are opposite reciprocals. So different sign and reciprocated. Different sign and reciprocated. So let's take a look and practice what opposite reciprocals are, or negative reciprocals. So I did say opposite because I meant opposite sign, so that means like negative reciprocal, opposite. So if it's positive, it's negative. If it's negative, it's positive. So here's some examples of opposite reciprocals. So let's say 3/4. Well, the opposite reciprocal of that would be negative 4/3. If we have 2, the opposite reciprocal of that would be negative 1/2. If we have negative 7/8, the opposite reciprocal of that would be positive 8/7. If we have 1, the opposite reciprocal of that would be negative 1, because 1/1 is negative 1/1. And if we have 0, by the way, 0 is over 1, the opposite reciprocal of that would be undefined because it would be 1/0, which is not defined. That was fun. Okay, so we saw here how to play with negative reciprocals. And why do we care again about negative reciprocals? Because perpendicular lines have slopes that are opposite reciprocals of each other. So let's go ahead and take a look at some examples of identifying parallel or perpendicular lines. Now, not every set of lines is going to be parallel or perpendicular. We can have lines that intersect each other, okay, like these two lines I've just drawn here, but perhaps they don't make 90-degree angles when they intersect. So they're not parallel because they intersected, but they're also not perpendicular because they didn't make a 90-degree angle when they intersected. So you're going to see here the question says, determine if the segments are parallel, perpendicular, or neither. which means it didn't satisfy either of the two conditions. So just remember that parallel means same slope, so the lines have the same slope. Perpendicular, the slopes are opposite. I'm just going to shorthand here. The slopes are opposite reciprocals, and neither means it didn't satisfy. It wasn't neither parallel nor perpendicular. It's just lines that cross. All right, so we have a line segment, and this is how you read this. Line segment AB is formed by these 2 points, and line segment CD is formed by these 2 points. So how do we determine if they're parallel, perpendicular, or neither? Well, to determine that, you want to find the slope. Find the slope for each line, and then compare. So let's find the slope for each line. So starting with line AB, all right, the slope is equal to 3 minus 6 over negative 2 minus 2. That's equal to negative 3 over negative 4, or just 3/4. Okay, so there's the slope of AB. Now let's find the slope of segment CD. So that slope is equal to y minus y, 0 minus 3, over negative 1 minus 3. That's negative 3 over positive 4. Over negative 4. There we go. Negative 3 over negative 4, which gives us 3/4. So our slope for AB and our slope for CD are the same, so same slope. Therefore, therefore, they are parallel lines. All right, awesome. So let's take a look at number 2. Let's find the slope for segment AB. So segment AB, the slope is equal to y minus y over x minus x. That's negative 2 over negative 5, or 2/5. Let's find the slope for segment CD. Slope is equal to y minus y over x minus x. That is 5 over negative 2. So we got to be really good at integers here. 5 over negative 2, which is negative 5/2. The slopes are not the same, but they are opposite signs and reciprocals. So the slopes are opposite reciprocals of each other. Therefore, they are perpendicular. AB and CD are perpendicular lines. All right, taking a look at number 3, we'll find the slope for AB. M is equal to y minus y, so 8 minus 6 over negative 1 minus 2. That's 2 over negative 3. There's my slope, or negative 2/3. CD, the slope is y minus y over x minus x, which is negative 1 over negative 4, or positive 1/4. Notice how the slopes are not the same. They're also not opposite reciprocals, so this is neither parallel nor perpendicular. Now they do cross each other, but they just don't make 90-degree angles when they cross. So we were given ordered pairs, and we used those ordered pairs to find the slopes and determine whether the lines are parallel, perpendicular, or neither. Now we're going to take a look at if we're given equations. How do we determine if they're parallel, perpendicular, or neither? So in number 9, you notice the equations y equals 7x plus 2 and y equals 7x minus 1. They're both written in y equals mx plus b form, so it's quick to grab the slopes. And you can see that the slopes are the same. So since the slopes are equal, those lines are parallel. Similarly, in number 10, also written in y equals mx plus b form, so it's quick to see that the slopes are opposite reciprocals, which means these lines are perpendicular. So obviously, y equals mx plus b form is really helpful because we can easily grab the slope. So in number 12, when you have a problem or an equation given in standard form and an almost finished slope-intercept form, what do you think we'll want to do? Well, we want to write it in y equals mx plus b form so that we can compare the slopes with each other. So if we take a look at number 12, we see that we have this one, we can one step to get it into y equals mx plus b. So we'll write this equation as y equals 6x minus 2. And then let's change this into y equals mx plus b. Let's start by subtracting x to both sides to get 6y is equal to 30 minus x, and then divide both sides by 6 all across the board. Y is equal to 5 minus 1/6x. Watch out here, as we've talked about how to write that slope. Minus 1/6x. I'm just going to write it the other way around. So y is equal to negative 1/6x plus 5. Now we can compare the slopes. I've got a slope of negative 1/6 versus a slope of 6. They are opposite reciprocals, so these lines are perpendicular. So I'd like you to try 11, 13, 15, all right, and pause the video so that then I can give you answers, and then we're going to do 16 together. Go ahead and try 11, 13, and 15 now. Now that you have tried 11, 13, and 15, you would have found that 11 is neither, because they're not opposite reciprocals and they're not the same. 13 is perpendicular. You should have gotten a slope of 5 for this equation and a slope of negative 1/5 for this equation. And 15 is also perpendicular. You should have had a slope of 1. Well, you could see it right there. Your slope of 1 for the first equation and your slope of negative 1 for the second equation. And take a look at 16. 16, you have a horizontal line, and horizontal lines have a slope equal to 0. You have a vertical line, and a vertical line has a slope equal to undefined slope. So they are perpendicular. 1, because the slopes are opposite reciprocals, and 2, because always a horizontal line and a vertical line will make 90-degree angles. That is the conclusion of Introduction to Parallel Perpendicular Lines. Thanks for watching. Thanks for learning.